Hello everyone. This video in this video I present the solution to example 10 on buoyancy. But this problem, if you're going to analyze, buoyancy laws cannot be applied. So here is the problem. In the figure shown, if the weight of the gate W in air is 4,450 newtons and H is zero point 0.6 meters, determine the force F required to lift the gate. Then in the second question, if h is zero point 0.6 meter, determine the value of W when a force of 13,350 newtons is required to lift the gate. And if the weight of the gate in air is 4,450, determine the value of H when a force of 22,250 newtons is required to lift the gate. So this is H, this is the force required to lift the gate. The weight of the gate is denoted by W and it is 4,450 in the first, and in the last question it is unknown in the second question. So the reason why we cannot apply buoyancy laws here, because the value of H, there is a value of H. Now if H is 0, these two will be level, then we can use buoyancy laws provided that the liquid on top of the gate and below the gate will be the same, just like in this situation here. So there's no situation where H is 0, therefore we cannot apply buoyancy laws here. So I want you to solve it in your free time. When H is 0, so they are at the same level, then apply the solutions I presented here and apply buoyancy laws, and the answer should be the same in one particular problem. So for the first, so let's have the upper part is subjected to a downward force, hydrostatic force, gamma bar its area. The lower part is subjected to an upward force, gamma bar its area. Then we have the weight also. So this is the free body diagram. F1 is due to the hydrostatic force of water, and it is gamma bar H area, where bar H is 1.5 minus 0.3 for F1. Then for F2, it is gamma bar H area, where bar H is 1.5, because this bottom portion, the center of this bottom portion is subjected to this water pressure, which tends to push it up. So the distance from this water surface to the centroid is 1.5 minus H. So in this case, if H is 0.6, so 0.9. But for F1, bar H is 1.5 minus the thickness, which is 0.3, so 1.2. So in other words, bar H for F1 is always 1.2 in this situation. Then we have the weight of the gate. So summation forces vertical equals 0. F plus F2 equals F1 plus, or W plus F1. So this is our working equation. So for the first question, F plus F2, where F2 is 9,810 newtons per cubic meter, times bar H, where bar H is 1.5 minus big H, which is, this is bar H, 0.9, times area, which is 1.5 meter square, 1.5 square, equals 4,450 plus F1. F1 is 9,810 newtons per cubic meter. Bar H is 1.2, 1.5 minus 0.3, so that's 1.2. And the area is also 1.5 square. So 9810, 1.2 times 1.5 square. Solving for F, F is 11,072 newtons. For the second question, if H is 0.6, determine the value of W when a force of 13,350 is required to lift the gate. So everything is the same because H is 0.6, except that we replace F by 13,350 and W here is unknown. So same equation, same terms for F2 and F1, except for F and W, which are given. So 13,350 plus F2 9810.9, 1.5 square equals W plus 9810, 1.2, 1.5 square. So solving for W, W equals 6728 newtons. Then for 10.3, if weight is 4450, determine the value of H when a force of 22,250 newtons is required to lift the gate. So this is 22,250. F2 is equal to 9810. Then barred H is now 1.5 minus big H. So we replace 0.9 by 1.5 minus big H. Area is the same. Then equals 4450 plus 9810, 1.2, 1.5 square. So this is always 9810, 1.2, 1.5 square. So 22,250 plus F2, which is 9810 times quantity 1.5 minus big H times 1.5 square equals 4450 equals W 4450 plus 9810, 1.2 times 1.5 square. So combining constant terms in the left terms, 55,358.75 minus 2272.5H equals 4450 plus this value here, 26487. So the only unknown here is H. Solving for big H is 1.106 meters. So as an additional problem, I want you to make H0, use the same equations, and for the first question using two approaches, using this equation here and using the buoyancy laws, and make sure that the answers are the same. So that's it, and this is the last example on buoyancy.